Finding perimeter and area in a coordinate plane. So today we're going to be able to find the area and the perimeter in a coordinate plane. We are going to look at using the distance formula to help us understanding that a coordinate plane is like a nice little grid. Here, a couple things that we do need to know is that what a polygon is. A polygon is any closed figure that has line segments and they have vertices. So you need at least 3 line segments to make a polygon, and that would give you a triangle. Other types of polygons would be a quadrilateral, has 4 sides, a pentagon has 5 sides, hexagon with 6 sides, heptagon with 7 sides, octagon with 8, 9 with nonagon, 10 decagon, 12 dodecagon, and on and on and on. And everything after that is going to be called an n-gon. So you can have a 15-agon. Things that you should know about here is that here, from B to C, we would call that side BC, if you're looking at that piece here. Here we have what we call a vertex, is where the pieces meet. That's going to be your vertex. This shape right here, this 1, 2, 3, 4, 5, this pentagon is going to be called pentagon A, B, C, D, E. When you name a shape, usually you go in alphabetical order, but whenever you name a shape, once you start going in a direction, you must continue going in that direction. So you can't call it A, C, E, D, D. That's a no-go. A, B, C, D, E, or A, E, D, C, B. Either one of those would be okay. To be able to talk about area and perimeter of shapes, we need to start off with the simplest of shapes. A triangle, a square, a rectangle. Really that means a triangle and a rectangle. Here, a triangle. To find the perimeter of the triangle, you literally add up all of the sides. That's what the perimeter is. Perimeter is when you add up the sides. So here you would have side A plus side B plus side C. That's going to give you the perimeter of any triangle. To find the area of the triangle, it is 1/2 the base times the height. So 1/2 the base times the height. And the height is actually found from a vertex down to a down to wherever it's going to form a right angle. So from here to here, this is going to give us our height. So 1/2 base times height. A square probably makes a square. Square, all the sides are the same. So the perimeter is just 4 times the length of one of the sides. So as long as you know one side, you know that it's a square, it's just 4 times that. The area of the square is length times width, and so that's going to give you S squared. For a rectangle, here it's a funny way of putting it, but the perimeter is still just adding up all of the sides. Here they have 2 times the length because there's 2 sides, and then plus 2 times the width because there's 2 widths. The area is length times width. So that's how you find the area of a triangle, square, and rectangle, and also the perimeter. We want to look at finding a perimeter. And if you can't see it, make sure you take notes of this part here. I'll read it a little slower. It says, find the perimeter of triangle ABC with vertices at A is -2, 3, B is 3, -3, and C is at -2, -3. To do this, the very first thing I'm going to do is I'm going to draw this so we can see what it looks like. So I'd like you to draw it as well. And label your axes. This is your X, this is your Y. Understanding that we don't all have access to graph paper right now, you should be able to create your own graph. Just pretty quick. It doesn't have to be perfect at this point, and that's okay. Understand that this is 1, meaning that this is 2, 3, 4, 5, 6. This in the Y direction also is counting by ones. And then I'm going to graph my points. So here, negative 2 comma 3. Negative 2 is in the x, 1, 2, and then positive 3, 1, 2, 3. This is point A. The next point is at 3 comma negative 3, so 1, 2, 3, 1, 2, negative 3. Here is point B at 3 comma negative 3. And then C is at negative 2 comma negative 3. C is at 2 comma. C is at 2 comma negative 2. And so now I have this triangle ABC. And for your sake, it should look something like this. We are looking for the perimeter of ABC with vertices A, negative 2, 3, B, 3, comma, negative 3, and C, negative 2, negative 3. In other words, this point right here is what we're looking for. To do such a thing, we're going to find each of these distances. Here, the distance. Here, it's going to be a little bit simpler. We would actually use the ruler postulate. This is in the y direction, so we're looking at 3 and negative 3. And we would say from A to C is going to be 3 minus negative 3, which is going to give us 6. Likewise, here in the x direction, I could say the ruler postulate again, 3 minus negative 2 is going to give us 5. And then here, we don't know. We don't know that actual distance, so what we would do is we would use the distance formula. D equals the square root of. And just like before when I said write it down every single time, make sure you write it down this time as well. That's x2 minus x1 squared plus y2 minus y1 squared. So then you have to choose which one's going to be your x1, y1, x2, y2. I'm just going to go from left to right. This is going to be my x1, y1. Yes, I will always physically write it up here, so then it makes it very simple to make that transfer over. And this is going to be x2, comma, y2. So now I can look at it and I don't have to think too much about what goes where. And so from there, I now have, and I'll write it in a different color so we can see the difference. D is now equal to the square root of x2, which is 3, minus x1, which is negative 2, squared, plus y2, which is negative 3, minus 3, squared. That leaves us with D is equal to the square root of 3 minus 2 is 5, squared, plus negative 3 plus negative 3 is negative 6 squared. And that leaves us with, or brings us to, D is equal to the square root of 25 plus 36. When I add these two numbers together, that gives me D is equal to the square root of 61. So this distance is now the square root of 61. The square root of 61 is not a nice, neat number that we're used to seeing, and that's okay. This right here is actually called the exact value. That's the exact value, the square root of 61. We still haven't found the actual perimeter yet. We would just add it to 6 plus 5. So now that we know that that's the exact value, we are going to go ahead and we're going to estimate this, square root of 61. Pull out your handy dandy calculator. Now please remember that your calculator should be something that looks like this. Something that looks similar to that. So now we're left with the square root of 61. So the square root of 61, D is approximately 7.8. I'm just going to add those together, 8.1. And we're going to find our perimeter is going to be 6 plus 5 plus 7.81. Find our perimeter. And our perimeter of triangle A, B, C is 18.81, and we didn't know what we're in, so whatever the units are 18.81 units. That's how I would write that out, just like that. From there, we're given a new problem. So we did say that we're going to look at both the perimeter and the area. And to do that, we're going to say, okay, find the area of triangle DEF with vertices D is at 1, 3, E is at 4, comma, negative 3, and F is at negative 4, comma, negative 3.
Likewise, skip line, triangle. So when you create your graph should always have an X and Y, so you know which way you're graphing. You also should always have, on your X and Y values, you should have something that's going to tell you how much you're counting by. So here I'm counting by 1s. And so here D is at 1, 3, so X is 1, 3, 1, 2, 3. There's D. D is at 1, 3. E is at 4, comma, negative 3, so 1, 2, 3, 4. 1, 2, 3. E is at 4, comma, negative 3. And then F is at negative 4, negative 3. 1, 2, 3, 4. 1, 2, 3. Lines up right across from here at 4, comma, negative 3, negative 4, comma, negative 3. Yes, and that is point F. So your graph
Should look something like this. Try to make it to the best of your ability, and for sake of argument, this is what mine looks like. So a couple of things to remember here. I'm going to go ahead and redraw this so you can kind of see it. If you cannot. So here we're finding the area. Thing to note. Area of a triangle, if we remember earlier back, the area of a triangle, area is equal to 1/2 the base times the height. Now the height, we also said the height can be found by looking at from the vertice, come straight down to a right angle here. So this is going to give us our height. The base, lucky enough here, can be found by the ruler rule on the x-axis. That's going to be the -4 and the 4. So from F to E, the distance from F to E is 1, 2, 3, 4, 5, 6, 7, 8. FE is equal to absolute value of 4 minus 4, which is 8. So FE is 8. The height here is, and we can just count, there happen to be nice enough numbers, 1, 2, 3, 4, 5, 6. The height is 6. And I'll just say the height is equal to 6 units, and we don't know what it's measured in. So here our area of this triangle. Area is equal to 1/2 times the base, which we said was 8, times the height, which is 6. 1/2 times 8 is 4. 4 times 6 is 24. Four, 8, 12, 16, 24. 24. Now it's not just 24, it is 24 units squared. this is actually important here, because you're actually looking at a two-dimensional space. It is going to be a square unit, so 24 units squared. And then you are done with that problem as far as area.